Hi, my name is Jess, and my presentation is on freeze tolerance plasticity in the intertidal mussel Mytilus trossulus. So Mytilus trossulus is a really common intertidal mussel species. And the reason that Mytilus trossulus needs to be freeze tolerant is because they're sessile. So this means that when the tide goes out in the winter months and temperatures drop below zero, they're susceptible to freezing. So what we did in our study was we collected mussels from Tower Beach, which is in Vancouver. We brought them back into the lab and we experimentally exposed them to one out of a variety of sub-zero temperatures, and then we assessed their survival. So we wanted to determine how the extent of mussel freeze tolerance changes with three factors: season, intertidal shore height, and changes in salinity. So our first prediction for season would be that intuitively freeze tolerance would increase in the winter months. For intertidal shore height, we would predict that freeze tolerance would increase with the increasing shore height. And this is because mussels found higher up on the shore are going to be exposed to air and therefore potentially freezing temperatures for longer durations of time as compared to their low intertidal counterparts, and therefore they would need to be more freeze tolerant. So what did we find? What this graph is showing here on the y-axis is lower lethal temperature. So that refers to the temperature that causes 50% mortality in a population of organisms. So as we go from July to November and January, you can see this decrease in lower lethal temperature, which indicates an increase in freeze tolerance because mussels are able to survive at more and more extreme temperatures. And then for shore height, we can notice that in November and January, the high intertidal mussels are significantly more freeze tolerant than their low intertidal counterparts, again, because they have this lower lethal temperature. So our next prediction would be that high salinity acclimation would increase mussel freeze tolerance. The reason for this is because freezing is an osmotic stress. So as you can see here, during the process of freezing, organisms will restrict freezing to their extracellular spaces. And this means that extracellular water is going to crystallize into ice. And this concentrates the extracellular fluid, creating an osmotic gradient. However, mussels are osmoconformers, so they can increase the osmolarity of their cells to match their external environment. So if we've acclimated them to high salinity environments, they would be better equipped to deal with the osmotic stress associated with freezing. So what did we find? Again, we found our results supported our predictions. So on the y-axis here, we have lower lethal temperature, and then on the x, we have salinity. So 15 parts per thousand is around half seawater and half freshwater. 30 parts per thousand is full strength seawater. And again, we see this really prominent decrease in lower lethal temperature in these high salinity acclimated mussels. Thank you.